My name is Hansong Zhou. This is a presentation for my final project. My project is research on anti-noise performance of OFDM system based on LDPC code. My presentation will be divided into 4 parts. At first, I will introduce the background and the project plan. The second part, I will introduce OFDM system and its technology and talk about the channel module used in simulation. Then I will show my simulation result. In the third part, I will introduce the LDPC code, include its advantages and the type we are going to use in this project. Then I will give a brief introduce about the coding and decoding process and the smart methods I will take in the decoding. At last, I will compare the performance of the uncoded OFDM system and the coded DF system. The last part is the conclusion of my project. So let's come to the first part. OFDM is one of the most widely used technology in the wireless communication system, such as the use in the 4G network. And one of its unique advantages is that it has excellent performance in combating frequency selective fading caused by the multipath effect. However, its ability of resisting inter-symbol interference caused by the multipath doesn't perform well without channel coding. And there are 2 major classifiers of coding in wireless communication system. One is the linear block code, and the other is a convolutional code. Convolutional code has been used in the past decades for its excellent performance of coding efficiency, which is close to channel limits. And turbo code is one of the outstanding coding strategies, but now it may be at a choke point due to the high speed of 5G system, that it can't support that extremely large throughput. While LDPC, a representative code of linear block code, is becoming a more suitable strategy in the future network. Therefore, this project is trying to apply LDPC into OFDM system to improve its performance. Our project plan will include the following 4 steps. The first is learn the concept of OFDM and LDPC and the process of LDPC coding and decoding. Second, we'll simulate the OFDM system in certain parameter and situation with MATLAB. Third is that I will evaluate the performance of uncoded and LDPC coded OFDM system. And last, I will give a conclusion and some advice on the further research. The second part is about the OFDM system. Orthogonal frequency division multiplexing is a type of digital modulation method of decoding digital data on multiple carrier frequency. Its main idea is to modulate a set of complex signal sequence on n carrier frequencies. Then the signal on the kth carrier can be expressed as follows. It's easy to prove that each subcarrier is orthogonal with each other by dot product a signal on kth carrier with a carrier frequency within a symbol period, and we can do the same at the receiver to demodulate. One of the key technologies in OFDM system is the cyclic prefix. It makes a big use in reduced ISI effectivity. Assuming the channel length is n, for a set of complex signal sequence output from the multi-carrier modulators, we copy the last L's value of the set to the front of the original set to get a new sequence called cyclic prefix. This cyclic prefix will extend the symbol period and absorb the delay in protect interval so that it can resist ISI by avoiding its influence on the transmission of the following symbol. Before simulation, we should choose the channel models. Here we are going to use the AWGN and the relay slow fading channel model. In the relay slow fading channel model, the envelope of the channel impulse response has a relay probability distribution and the phase obeys a uniform distribution. Then the simple values can be described as the second formula. As for a narrowband signal, the received signal at a certain time is only related to the transmission signal at the current time, and ISI will hardly appear in the receiving signal at this time. So we're not going to focus on this kind of signal. However, as for the wideband signal, the receiver signal can be written as a third formula, where L represents the length of the channel and the value of Hn changes every period of the frame. Using MATLAB, I simulated the performance of OFDM system when the wideband signal are modulated by QPSK and the 16QAM separately. Here, we create 10,000 frames of data on total, with each frame containing 10,240 bits, and we use 256 subchannel and the length of relay slow fading channel is 32. According to the different curves in the same pictures, we can find that no matter how subclear in QPSK or 16QAM modulation mode, the system performance of relay slow fading channel is far worse than the AWGN channel, because the characteristics of the relay slow fading channel will amplify the effect of noise on the transmission signal statically, while AWGN will not. Then go to the third part, LDPC codes. Its full name is Low Density Parity Check Code. It's a linear block code based on sparse matrix. Compare it with the turbo code, it has following advantages. First, it's easy to achieve in hardware for its parallel algorithm, and it has lower computing costs, and it allows larger throughputs, and the data rates can be constructed. Although the original coding process of LDPC code is more complicated than turbo code, but a new kind of LDPC code called quasi-cyclic LDPC code can solve this problem. So how is LDPC code coding? LDPC code is a linear block code given by the generator matrix. In other words, the generator matrix of linear block code will determine the relationship between message and the code word. But it's so hard to start coding with the generator matrix for its high density, because the generator matrix and the low-density check matrix have a one-to-one correspondence. So we usually start with check matrix. Here we give an example of a check matrix. It's a 10-5 linear block code with row weight 2 and a line column weight 4. The row weight means that each row has 2, 1, and the column weight means that each column has 4, 1. And so for certain check matrix, it can be regarded as two parts, and the code word C in the system style can be represented as the second formula. According to this equation, we can get the check bits easily by the force formula. Then we can get the whole code word. The decoding process of the LDPC is much more complicated than the coding process. In this section, we use Tanner graph to represent LDPC because it can make the description for decoding algorithm clearly. There are many methods to decoding LDPC code. Here we choose the leaf propagation algorithm, and also called sum product algorithm. In this algorithm, timetable methods are time-consuming in hardware implements. Therefore, a simpler update equation for nodes should be taken. Here we take an approach similar to the SPA algorithm. The minimum sum decoder, we call MSA. Here, the check nodes update equation is given as this formula. The calculation has been significantly simplified, and in the region of BR we are interested in, the performance of these two coding algorithms is very close. Then we give the simulation results here, and the condition is as follows. We can see that the curve of MFB under relay slow fading indicates the optimization limit that the corresponding system can reach in theory, and the gap between this curve and the BR of current system under relay slow fading channel can be used to evaluate the performance of the current system. What means the smaller gap corresponds to better system performance and the less potential of system optimization. Now look at the simulation result. With the BR performance required of 10.5 in 16 QAM modulated system, the difference between the simulation performance and the theoretical optimization limit is only about 4 dB. So it's very close to the limitation. And then we compare the simulation results in Figure 4 and that in Figure 2. It's obvious that the OFDM system performance has been greatly improved with LDPC code. For example, for the BR here, this SNA required is uncoded system is more than 13 dB, while that in the coded system right here is only about 12 dB, which means that the LDPC code has brought nearly 20 dB performance improvement to the system. Therefore, these simulation results clearly show that the LDPC code has an obvious optimization effect on OFDM system performance. Now that comes to conclusion. The LDPC code is a linear block code. Its characteristic is sparse check matrix, which means its decoding complexity is very low. With the sparse check matrix of the LDPC code directly, the coding complexity can be highly reduced. By comparing the PR of the uncoded OFDM system and the LDPC coded OFDM system with different modulation methods, we can find that LDPC can effectively reduce the influence of deep fading subchannel on system and improve the performance of the OFDM system. My presentation ends, and thanks for listening.